Hey, fast-paced students, let me go over, I think this is going to be your last lesson for your quadratic unit, and then we'll start preparing for our test. For today's lesson, we're going to look at quadratic word problems, where you can apply the quadratic property, or the quadratic formula, I should say, and use it to help you figure out any type of real-life situation where it involves like most of my examples here involve some sort of parabola or parabolic curve. Like kicking a ball, hitting a golf ball, throwing a football, punting, all those things. Jumping off a cliff, don't do that. But anything that's parabolic, these quadratic equations are going to be helpful for solving it. So let's go ahead and look at our first example here. You'll notice that on your other page, there's room for a graph. But before we start graphing anything, let's find all the important information that we need before we start putting parabola on the graph and labeling things and make sure it's all correct. This first problem, it says here right here, punter kicked the football into the air with an upward velocity of 62 feet per second. Its height, which is h, in feet after t seconds is given by the function, have this, they're very similar looking. They have this negative 16 t squared value as the leading coefficient. And that's kind of how these kind of turn out, but don't let that throw you off. Okay, so we've got the function h equals negative 16t squared plus 16t plus 2. And remember, t is going to represent your time. And we need to figure out what the maximum height of the ball, what is the highest point that it reaches. All right, so that's one thing. And then another thing that we need to figure out is how long will it take for the football to reach the maximum height. So that's going to be the time element. And then the third thing is we want to know how long will the football basically be in the air before it hits the ground. So there's going to be all those things. So if, just doing a really terrible rough sketch of this, if you're going to do this, well, obviously the football is going to leave the foot and it's going to follow that type of curve. Okay, so if this is t and this is h, well, as long as we can figure out the vertex, we'll figure out the height. If we can figure out what those roots are, that will represent the time. Now, obviously, we're not going to count that as the time because we have to start at 0. But we're gonna count the time from here to there that the ball was in the air. So the ball left the punter's foot at that point, and then it hit the ground right there. So one of the roots is going to tell us what the time is. So that is what we're going to do. So you can see where quadratic formula is going to kind of come in handy here. The first thing I want to do is let's figure out what that vertex is. Figure out that vertex. And if you remember, the vertex formula is going to be x equals negative b over 2a. And that will tell us, well, actually, that tells us our axis of symmetry, which in turn basically just tells you, it's going to tell you the apex of that parabola. It's going to tell you where the very tip top of that parabola is going to be. So the axis of symmetry is going to be determined by doing that x equals negative b over 2a. If we do that, let's just go ahead. This is why I gave you guys a lot of room to work. So b, let me just kind of write things out. A equals negative 16, b equals 62, and c, our constant, equals 2. So negative b is going to be negative 62 all over 2 times a, and negative 62 over 2 times negative 16, well, that's going to be negative 32. And negative 62 over negative 32 makes positive. And then you got 62 over 32. Now you can reduce that if you want to, but I'm just going to divide that. So that's 1/2 of our vertex. Remember, when you guys figure that out, you figured out the x value. Now when you get the y value, what you're going to do is we're going to find the y by substituting the x value in there. So we're going to take that entire quadratic equation, which is negative 16, and then instead of writing t squared, I'm just going to write parentheses that are blank squared plus 62 times t plus 2. Now, if I'm confusing you here because I'm referring to it as the x, I mean, really, we're finding the t. This is going to be our h. Okay, so our t represents our x, it represents our x-axis, which is our time. And typically when you're in any math class you're going to be in, your time is always, I'd say 99 times out of 100, it's going to represent your horizontal axis, your x, and anything height related is going to be your y, which makes sense. Okay, so you have, this is t for time, and h is going to be your y. So that, sorry if I was using x and y to refer to these things, but you know what I mean. The first term is x, the second term is the y. So what I'm going to do is I'm going to put our approximation for t, because we had to round, that's not perfect. 1.9 is not the exact answer, but it's going to serve its purpose for trying to figure out this graph here. Okay, so I went ahead and I opened up my calculator app, which it will solve it for me, and you guys can put it in your calculator as well. So when I do all that, I got 62.04. So it's around 62.04, and I'm just going to round that to 62. That's our vertex right there. We figured out our t, which is our x, and our height, which is 62 feet. So actually, we just answered one of the questions, which is what is the maximum height of that ball? And that's going to be it, 62 feet right there. All right, so let's keep going with this. And now we need to figure out, how long it's going to take to do all those things. And here's where it's going to be a good idea to find the roots. And if we're finding roots, we're going to probably want to use the quadratic formula. So our b value is 62. Our a value is -16. And our constant is 2. And like I was doing yesterday, I'm going to try to break this down into as few parts as possible before we start doing any crazy arithmetic here.
But -16 to 64.
Now, when I go to my calculator app, remember what I said yesterday, which is try not to put too much in, otherwise it may get a little bit too tricky with some of the functions you're using. So I'm just going to put the numerator in right now. I'm not going to put plus or minus. I'm just going to do the plus first. Square root of 62 squared plus 128. And I'm going to hit calculate, and then that comes out to be 1.023805, and I'm not going to round that. I'm just going to hold on to that. Don't clear your calculator. Just kind of keep that as is. If you round that and if you turn that into 1.02 or something, you might end up with these things called rounding errors. I think I talked about that yesterday, but I could be wrong. But the rounding errors can throw off your answers a little bit. And if we're trying to be as precise as possible, let's try to keep the rounding to as few steps as possible. And the last step is for us to divide by -32. So there's one of my answers. So I'm going to write that down. And that's -0.31993 ... So I'm going to probably just round that to -0.03. Okay, now for the next one, I'm just going to do the minus version of this. And you get -125.028 or 3805, all that kind of stuff. And then I'm going to divide that again by -32. And see how that comes out. That comes out to 3.09. 3.90, I mean. So if I round that to the nearest tenth, 3.9 will do fine. So positive 3.9. Now I'm going to go back to my work. I know there's a lot of back and forth here. So our roots, which is going to give us enough information here to figure this out, our roots are going to be negative 0.03, so pretty much 0. It's like pretty darn close to 0, and 3.9, positive 3.9. I went ahead and I just wrote down the quadratic equation, or not the original quadratic equation that was given for problem number 1. And I just want to talk about this for a moment. We talked about this before the coronavirus thing happened, and it wasn't a huge discussion. But right here, that's your y-intercept, which is good to know because in this case, it's really our h-intercept, because our h-axis is representing our y. But that is where it goes through the y-axis, and that makes sense because this problem is talking about a football punter who's kicking the ball. So obviously, when you're kicking the ball, you're not going to kick the ball at ground level. You're not going to hit it there at ground level. You're going to hit it somewhere above ground level. Okay, so I went ahead and I just wrote down kind of all the important information here that we need to solve this. What I'm going to go ahead and do is we've got the vertex, which is 1.9 and 62. The roots are negative 0.03 and positive 3.9. And our axis of symmetry was 1.9. I'm going to mess around with the intervals a little bit, but I'm going to make the y-axis, I know it's really the t-axis, it's time. I'm going to make those intervals of 1. So I'm going to make this represent 1, I'll make that represent 2, 3, and 4, and that actually works out perfectly because I just need to be able to graph all the way to 3.9 and kind of estimate where 3.9 is. Or not 3.9, I'm going to estimate where the axis of symmetry is, which is 1.9. Now 1.9 is really close to 2. So here's our axis of symmetry. Our axis of symmetry is really pretty close to 2. And that's actually probably not close enough, but it's going to work for doing a hand-drawn parabolic graph. And our vertex is 1.962, and so if I want to mess with the intervals here on the y-axis, which is really the h-axis, let's go by tens here. So I'll make that 10. This will go to 20, 30, 40, 50, and 60. All right, so those worked out nicely. And so 62 is just going to be a little bit above. I'm just going to kind of guesstimate that it's like right there. And that's your vertex right there. Another thing too, I didn't write this down, we talked about it. Another thing that's pretty important in this problem is that we figured out our y-intercept, which was 2. That's 5, so that's like 2.5. So 2 is going to be like right around there. And again, I don't need to be perfect. I just need to be close. NASA's not looking at my measurements here and wondering if I'm doing them the right way. I just have to be close for the purpose of this problem. And then our roots were what? Our roots were negative 0.03, negative 300, which is just negligible. It's really, really close. If I zoom in, that's probably even too far, but it's probably like right there. I'm just going to put it right there for right now. And it really doesn't matter that it's right there because you'll see why. It doesn't really matter what that root is. The other root is more important. Our other root was 3.9, which is all the way over here. And now we have all the information that we need to make our parabola. So our parabola takes off right here, really close to 0. But right there is the punter's foot, obviously. The punter's foot is above ground. So that's where the punter hits that football. Let me kind of zoom out here and just kind of, I'm probably not going to draw this great, but let's see. Okay, so we're through with all the hard stuff here, and which was graphing it. And I know I'm talking quite a bit about this, but I mean, there's a lot to this. I mean, this is really the culmination of your quadratic unit right here, which is being able to take a real life problem and graph it and kind of make some visual sense out of it and just see what it looks like. And this is exactly how this works. If you ever see that movie, it's called October Sky. The kids determined, and they used a little bit of trigonometry, but they determined that the rocket that they launched, and they were dealing with model rockets at the beginning, couldn't have been theirs because they figured out the parabolic trajectory of the rocket that was flying from the location where they launched it from. Right here, let's kind of talk about this for a moment and just make some sense out of this. There's a few questions here. One of the questions was, what's the maximum height of the football? And the maximum height is around 62 feet. It also asked how long it takes to reach that maximum height. Well, the maximum height is the axis of symmetry. So this being 0 times 0 seconds, and this right here is 2 seconds. The time is from here to the axis of symmetry. All right, so that's around, and I'm always saying approximately because we rounded this. That's 1.9 seconds to reach that apex height, that maximum height of the football. And then if we want to figure out what the entire length of the football being in the air was, that is going to be the distance from 0 to the positive root right there. And then we figured out that positive root was around 3.9 seconds. And so that's pretty much the answer. So the ball was in the air for around 3.9 seconds. It reached its halfway point. It reached its maximum height at 1.9 seconds. Now for example 2, what I want you guys to do is, why don't you pause the video at this point and try this one out on your own and just kind of go through the whole thing where, it's going to be important for you when you figure out these problems. You want to find the vertex, you want to find the axis of symmetry. That's stuff that we've learned. You're going to want to find, what else? The y-intercept, which is basically just your constant. Figure out all those points, figure out your roots, and then you're going to have enough information to graph it and solve it. But why don't you go ahead and just pause it and just see how everything compares to what I got on mine. Hopefully I do mine right.
Let's give this a go.
Okay, now let me stop here and just kind of just make sure we're all on the same page. I figured out the vertex. The vertex was basically 0.6, if I want to round that, 0.63, I guess, and then 12 1/4. That's our vertex. Also, that's our axis of symmetry right there, AOS. Our roots are -1/4 and 1.5, and our y-intercept is 6. So you probably don't want to move on if you don't have those numbers, and you might want to look at your arithmetic. This one, I didn't really have to use a calculator too much because that was a perfect square. That's a perfect square of 28. 28 times 28 is 784. And so that gave me rational roots. They didn't come out irrational. I didn't have to round anything in terms of the roots. Okay, so for example 2 here, we're looking at a frisbee. A disc is thrown into the air with an upward velocity of 20 feet per second. Its height, h, in feet after t seconds, just like the last problem, is given by the function h equals -16t squared plus 20t plus 6. And just like on the last problem, we're going to figure out the maximum height. We're going to figure out how long it took to reach that height and how long it took to hit the ground. How long it took before the disc was 3 feet off the ground. And so that actually adds another element to this problem. So 3 feet off the ground, I'm going to look for when the height is 3. Okay, so for this next part here, I want to figure out how long it's going to take to be caught 3 feet off the ground. And so I'm going to take the original equation, which is -16t squared, and then it was, what was it, plus 20t plus 6, and then make that equal to the height. Now the height is, for this particular problem, we want to figure out 3 feet. So what I'm going to do is make that equal to 3 instead of making that equal to 0, and then bring that over. Oop, I forgot the t there. And then I'm going to do it like that. So we've got here same a as before. We've got the same b as before. And different c. So for this one, I got 1.385 something something. I'm going to round that to 1.4. Okay, so I'm going to jot down all the relevant information that we've figured out to this point. Okay, so there's all of our information graphed, and we can kind of see how everything kind of turns out. And everything's there. We have everything we need. Obviously, its maximum height is right here. It was 12 1/4 feet, right about there. Also, how long did it take to reach that maximum height? That's the time it took to go from here to here, and that is exactly 0.625. And how long did it take to hit the ground? Well, that was like 1.4 seconds. How long was the disc? We didn't actually have to figure that out, but if we wanted to figure out how long it actually hit the ground, that would have been 1.5. But there it all is. I know it's a little messy. Your graph is good enough. We have all the relevant information there that we need. Now, you guys, for your assignment, I want you to go ahead and solve example 3. That's it. That is all you're going to have to do is figure out example 3, solve that. And it says a golf ball is driven in the air towards the hole from an elevated tee with an upward velocity of 160 feet per second. Its height, h, in feet after t seconds is given by the function of h equals -16t squared plus 160t plus 18. How long will it take for the golf ball to reach its maximum height. What is the ball's maximum height? So I want you to go ahead and answer those questions there. Use the Vertex Formula, use Quadratic Formula, and then graph your solution in the graph provided. What I want you to do is whatever work you do, I want you to take a picture of it or scan it. I don't care how you do it. Take a pic with your phone or your computer, take a picture or scan it, and I want you to turn it in. So attach it to a Google Doc. I think that'll be easiest for me to check. Attach it to a Google Doc and then turn it in to me and show me what you got for number 3. I'll grade it and I'll turn it back into you. That should be it. All right, everyone have a great day. And please let me know. I know this was a lot, but these take quite a long time to do. You don't have to do number 4. I know I have number 4 on here as well. You can skip number 4. Just skip that one altogether. All right, everyone have a great day. See you later.